from Dublin, California. Quarry Lane, show us what you've done.
Can everyone see the screen? All right. Hey everyone, we're the Quarry Lane InvenTeam, and just going down from left to right here, we are me, Bridget, and then Harini, Christine, Bryson, Isha, Varshini, Krithik, Karina, and Rachel. Our invention is an effort to help communication between athletes with hearing loss and then sports officials as well as coaches during the game. And we're all super excited to share with you our process and progress with you, so let's do it. Our inspiration for the project came from one particular team discussion where someone brought up a basketball game she played at against the California School for the Deaf in Fremont. Quite often, after the referee's whistle was blown, the opposing players would carry on to finish up a layup or complete a play, unaware that there was an auditory signal to do something else. While hearing loss has no impact on athletic ability, it does impact the flow of the overall game. For example, if a player doesn't notice when the whistle sounds, then the team loses vital seconds in setting up their next play. This also impacts the team's strategy when the coach is trying to tell the team to run a play but can't get the player's attention. So after some discussion, the community problem that we identified was that basketball players with hearing loss have no way of responding to referees' whistles. And then by extension, our team's goal is to reduce these communication delays by improving a player's reaction time to an in-game signal, like a whistle. Through a lot of discussions within the team and interviews with coaches who have worked extensively with athletes who are hard of hearing, we came to the solution of alerting a deaf basketball player through another sense, haptic vibrations. Our device integrates with the referee's whistle, where when the whistle is activated, the device sends a wireless signal that causes a player's wearable device to vibrate. This vibration will communicate specific messages like a dead ball or a coach's further instructions.
Okay, so to understand where we wanted to go with this project, we had to look at the other products that had been made. So firstly, we have the US patent, which is a patent that assists players who are hard of hearing during sport games through a multi-step system involving a whistle, a computer, and a wireless transmitter. It alerts the players with the vibrational vest, a loud horn, or visual signals. Secondly, we looked at the Unitac bracelet, which is an invention that uses a phone as a trigger device and has a bracelet connected to it via Bluetooth. It's intended to encode different haptic patterns to symbolize different messages. And lastly, we saw this Wii Sports, which is a product that works with a trigger device on your finger and a haptic output on the arm pad.
So what makes our device unique from other existing products? Our device is situation specific. The previous products that we mentioned are not specifically designed or intended for use in a basketball game, so they do not account for the game's fast pace or safety hazards. Our device is convenient. Our device is quick to set up, and it's also easy to incorporate with existing gear or implement into a game without a third person's support. Our device is finally adaptable. It is necessary to incorporate existing standards of a basketball game so it can be easily used in any situation. So this is what our device does. So we don't have to design a completely new system because of its adaptability. All right. Now let's talk about our physical prototype.
To evaluate our invention, we checked it against the design criteria that we set for ourselves at the beginning of the project. Our device is safe, comfortable, durable, and unobtrusive. Multiple team members tested it while playing basketball and reported no issues with the device. It is also policy permitted, as the current design of the device is allowed to be worn in-game according to the NFHS rulebook. The goal for our device is to improve the reaction time of a deaf basketball athlete to a referee's whistle. By watching basketball game footage, we determined the current average reaction time to be around 2.5 seconds. Unfortunately, due to the ongoing pandemic, we haven't yet been able to send our ready-to-wear prototype for testing with our partners at Deaf Camp Pacifica and California School for the Deaf in Fremont. Instead, our team did some basic testing ourselves. With our first full prototype, we conducted 10 trials and determined the average reaction time to be 0.62 seconds. So we're pretty confident that our device will be helpful. Now here's a quick breakdown of how our system works. First, the referee is using an electronic whistle, which is a whistle that makes a sound when a button is pressed instead of when it is blown. When the button of our trigger module is pressed, it triggers both the sound from the e-whistle and a wireless radio signal, which is sent to the player-worn device. When the player-worn device receives the signal, it vibrates using a vibration motor so that the player can feel it and be aware of the referee's call. Here are the two main components of our invention: the trigger module and the haptic wearable device. As you can see, the trigger module sends a signal to the wearable device, which vibrates the haptic motor. In the next slides, we will go over the details of each.
For our trigger module, we decided to make it into an add-on component that rests on the outside of an e-whistle instead of actually integrating into the original electronic system, because it is more adaptable and transferable to different e-whistle. The referees are more likely to accept it as the e-whistle hasn't been tampered with. This adaptable concept of our design makes it unique and stand out from other products. As you can see, our trigger module has a push button that sits on top of two other buttons, the button of e-whistle and the button that sends the radio signal. When the push button is pressed, it will simultaneously cause the e-whistle to emit a sound and the radio transceiver to send a signal to the haptic wearable device. Now let's take a look at the components inside the trigger module. Consists of a Fox 40 electronic whistle and a 3D printed casing that contains all the electronics. The current casing is specifically designed for the Fox 40 since it is widely used by the referees. The two main components inside the casing are the NRF radio transceiver and the Arduino Nano. The radio transceiver is used to transmit a signal to the haptic wearable device, which is connected to the Arduino Nano. We tested code that allowed transmission to more than one wearable device. The radio transceiver also has an antenna, which ensures a coherent transmission even when there are many obstacles. Additionally, the Nano board is connecting with a battery and the button that controls the electronic system.
All right, now onto the haptic wearable device, and this module will be worn by the player and it vibrates when it receives a signal from the previously described trigger module. These pictures here just show the electronics, and that includes a rechargeable LiPo battery that charges through a USB-C cable. You can see it working in the top right picture. And there's also a really cool light that turns red or green, depending on whether the charger module is charged or not. And additionally, the slide switch on the left side picture turns the device on and off. The Arduino and radio transceiver are also pictured, and they're like the brains that run the code and receive signals. All the electronics fit snugly inside this 3D printed casing you can see in the bottom right, and it closes shut with a lid. The one exception is the vibration motor, which has its own separate casing and sticks out, because when we tested it, we actually found that it's a lot easier to feel the vibration when it's separated and on its own. All right, and once those electronics are secured in their little box, the entire thing slides into a fabric band. This band is custom sewn and it has a pouch for the electronics box and a separate pouch for the vibration motor, and this ensures that neither of them slide around during the rough contact of sports. The band is wrapped around the player's ankle, slightly above and on top of the sock so that it doesn't slip, and it stays secure with Velcro. On the right side, you can see some of the materials we used, and the fabric is made of a spandex and cotton blend, which is similar to most athletic attire. There's a layer of Velcro at each end, so that there's lots of room for tightening adjustment. And onto the wireless connection. Here, this video is a demonstration of the device being worn and used while running. And to achieve that wireless connection between the two devices, we're actually using radio transmissions because radios allow us to connect multiple receivers and multiple transmitters, which means we can accommodate for an entire team of deaf players, and we can also accommodate for multiple referees and coaches. At first, we weren't completely satisfied with the range of the device, so we added an antenna to the trigger device that allows the signal to work perfectly at a distance of up to 150 feet, which is more than enough to cover the length of a basketball court. And you can see that in the rightmost picture, that's us testing the range in a parking lot.
We've reached a major checkpoint with a successful prototype, but as a team, we plan to continue this project on our own in the future. Now, in terms of next steps, we plan to test with our outreach partners to get direct feedback about our overall system so we can make updates and adjustments accordingly. For the trigger module specifically, we aim to produce a more compact version of its casing that fits on other whistles besides the Box 40 brand, and in addition to some updates on the electronic system. For the haptic wearable device, we plan to adjust the materials used in order to make it more ergonomic. Finally, we want to submit an official patent. We've already filed a provisional patent that gives us 12 more months to develop our product.
We would like to give a special thanks to the California School for the Deaf in Fremont and Deaf Camp Pacifica for working with us on our project as our wonderful partners. We also want to thank the Level 7 MIT program and the Quarry Lane School for giving us this amazing invention opportunity and for their support.
Thank you so much, everyone, for listening. Please consider following us on Instagram and checking out our website. You may also reach us through email posted in the chat with any questions, feedback, suggestions, or if you would like to see how you can work with us.
Thank you very much. What a great idea. We've got some questions for you. What if this device gets hacked or gives a false signal? Did you talk about that or consider that?
Okay, that's a great question. I think Kritik can take this one if you wanted to.
Yeah, so the radio transceiver, it's not really connected to the internet as we've said, so I doubt it would really get hacked. However, in case like, if you're wondering about like if the radio transmission like, I guess it could be like intercepted or something. Well, since like there's a direct connection between like the transmitter and the receiver, I doubt that would really happen. And next, for the second part, for false signals, it is one of the reasons why we chose this NRF module, since its transmission strength and consistency was like a lot better compared to the previous ones we were testing near the start of the program. So yeah, it's mainly why we chose the radio. It's much stronger.
Have you thought about other applications that this technology could work really well for? Maybe starting blocks on track events or other types of things?
Yeah, that's a really good question. We have been considering adapting this for different sports. I think Karina can elaborate on that.
Yeah, so that is a recommendation we've been getting a lot, and we actually consider it at the beginning of the project. Not only applying it to different sports, like a starting block for track meets, or even kind of adapting it to a light signal for like, a swimming competition. But we've also looked at some other products that do use it just in everyday life, kind of getting people's attention, just like hanging out. It's kind of like in that case, it's more of like a smaller, more discreet wristband that you wear, and then kind of like your friends can like, if they want to call you over, they can, buzz it or something. So yeah, that's definitely something we want to expand into as part of our next steps and next features.
Amazing. What inspired this idea? How'd you kids choose this product to develop this invention?
This idea originally come from one of our teammates who, when she was playing a basketball game with the players at California School for the Deaf, and we were kind of inspired from there.
So you know the customer, that's really exciting. Does the referee have to point the electronic whistle in the general direction of the players in order for the receiver to recognize the whistle being blown?
So actually, no, if the referee is just in the range, they would be standing generally on the side of the court. So if they were just to press the button, all of the players who are wearing the wearable device would be able to receive the signal.
And just to add to that, that's actually another perk of kind of applying it to a basketball game, is that in general, the court is kind of like the same size. Most of the players are usually in the same direction. So that kind of helps, like the situation makes it a little more consistent, that in the case that the antenna were pointed slightly in the wrong direction, the wearable devices should receive the signal.
Great. Can you show your Instagram again? And this is a great job. Congratulations on all the progress you made in spite of the pandemic and everything. It's a very exciting invention.